Welcome back to our geometry series. Today we are up to section 3.2 where we will be proving triangles congruent. Here are our good friends, triangles ABC and DEF. When we last looked at these triangles, we compared their angles and their sides. So if we said that each corresponding angle was congruent and each corresponding side were congruent, that would show that the triangles were congruent with each other. This is actually the definition of congruent triangles. But what if I told you there was an easier way? Looking at these two triangles again, let's look at just the sides. What if only the sides were congruent and we knew nothing about the angles? This is actually postulate 14, the side-side-side postulate. If three sides of one triangle are congruent to three sides of another triangle, then the two triangles are congruent. In other words, if all you know are the sides to be congruent and nothing about the angles, the triangles are still proven to be congruent. Let's take a look at another one. Postulate 15, the side-angle-side postulate. If two sides and the included angle of one triangle are congruent to two sides and the included angle of another triangle, then the two triangles are congruent. So here the important part is the word included. If you look at the two triangles, the two sides that we have that are congruent, the angle in between them are also congruent. So this is the included angle. And it's the reason we write it as SAS, side, angle, side, because that's the order they appear in the drawing. Let's take a look at another one. If we have the two angles and the included side, that leads us to postulate 16, the angle-side-angle postulate. If two angles and the included side of one triangle are congruent to two angles and the included side of another triangle, then the two triangles are congruent. Again, the word included is important. It's the side that's in between the two angles that we know are congruent. Now let's take a look at one more example. Here we have two congruent angles and one congruent side, but this time the side is not included. It's not between the two angles. This leads us to Theorem 30, the angle-angle-side theorem. If two angles and the non-included side of one triangle are congruent, respectively, to the corresponding angles and non-included side of another triangle, then the two triangles are congruent. So just like before, the way we write the theorem AAS shows us that the side is not included. It's not between the two angles, but this will still give us two congruent triangles. So we have found four new ways to prove that two triangles are congruent. SSS for side, side, side. SAS for side included angle, side. ASA, angle included side, angle. And AAS, angle, angle, non-included side. Now you may be wondering, what about something like angle, angle, angle? We could have two triangles that have congruent angles, but their sides could still be different lengths. These would be similar triangles, but not congruent triangles. One could be large, one could be small, having the same angles, but they would still not be congruent. So we can't use angle, angle, angle. Angle, side, side also doesn't work, because that would be inappropriate. Let's jump over the whiteboard and look at some congruent triangles. Alright, let's draw two triangles here, something like this, and something like this. Let's say we've got an angle and an angle that are congruent, and we've got this angle and this angle. I'm going to draw little dots through them. These angles are congruent, and we'll say this side and this side. So are these two angles congruent, and if so, what theorem or postulate says so? Well, we have an angle and an angle. So we have two angles and a side. The side is not included, so we have two angles and not included sides. So this would be angle, angle, side. So these are congruent. What about a triangle like this and a triangle like this? And we'll say we'll put some letters on here, A, B, C, and D, E, F. And we know this side and this side are congruent, and this side and this side are congruent. And we know this angle and this angle are congruent. So ABC and DEF, those are the corresponding angles and sides. So we have two sides and an included angle. So we have side, angle, side. So when you have a proof, this would be the reason that you could say that these two triangles are congruent. I'm going to draw something a little different down here. Let's be on the screen, please. A triangle and another triangle. Now they share a side. So I'm going to say that this is congruent to this, and this is congruent to this, and that's it. Are these triangles congruent? Well, it's a little bit tricky because this side of this triangle is the same as this side of this triangle. So they share a side. So this segment, let's just call it AB, right? And we can call this C, and we can call this D. A and B, AB is a segment of both triangles. So we have side, side, side congruence between triangle A, B, D is congruent to triangle A, B, C. AB is the corresponding segment on both of these triangles. That's it for today. Let's just stick around. We're going to do a quick proof using these theorems and postulates. Okay, we're going to start with a box like this. And then we'll kind of cut it down the diagonal, and we'll put some points on here. R, O, S, and E. And I'm just going to number some of these angles here. 1, 2, 3, and 4. Now let's talk about what's given. This is what we know about these features. And we're going to say that RE is parallel, segment RE is parallel to segment RO, and OS is perpendicular to ES, and I could probably squeeze this in here. RE is parallel to OS. Yep, that's on there. RE is parallel. So let's make some marks. So RE parallel to OS. Okay, so I'm going to put this little arrow on here to show that these are parallel, RE and OS. And so RE is perpendicular to RO, so that's this here is 90 degrees. So 1 plus 2 would be 90, and ES and OS, again this corner, similar thing. So let's write out the proof. We're going to have the statement. That's a statement, I promise. I'm going to draw this all the way off the screen. And then we're going to make a little column here. And this is the reason, the important thing. Why are we allowed to say that? So let's just start with RE is parallel to OS. All right. How do we know this? Well, it's right here. So we can say that it's a given. That's easy enough. Now the next one, I'm going to say that angle 1 is congruent to angle 3. So how do we know that? How can we just say this? Angle 1 is congruent to 3. Well, we learned in the past that when you have parallel lines and they have a transversal, a line that connects two parallel lines, the alternate interior angles are congruent. So I would say, if parallel lines have transversal, that's kind of on the screen, then alternate interior angles are congruent. I'm using shorthand, and your teacher may or may not allow you to do this, but now we've proved that angle 1 is congruent to angle 3 because of this property. So what I'm going to do is just draw it like this. Bloop and bloops. Now 1 and 3 are congruent. We know that. Well, if that's the case, we could say the same thing, that angle 2 is congruent to angle 4. And it's the same reason, right? This whole blob here is true for this and for this. So I'm going to make that little thing, I'm going to do the two little circle chunks here to show that 2 and 4 are congruent. So we have two angles, so we're getting there, but it's not enough to show that these two triangles are congruent. I guess I never showed what we're trying to do here. Given we are trying to prove that triangle RES is congruent to triangle SOR. So this becomes part of the puzzle, part of the investigation. What else can we say about this figure to try to prove that these two triangles are congruent? Well, just like the last problem we solved before we cleaned the whiteboard, we have a common side. So this looks kind of weird. I'm going to say that RS is congruent to SR, these segments. RS of this triangle, right, is congruent to SR of this triangle. So this is, you almost want to say the reason it's common sense, but you could say property of line segment, right? This segment has to be congruent to this segment because they're the same segment. So now we know that I'm going to put a line here, and it's weird because it's a line on top of itself, but now we have an angle, a side, and an angle. So now we can finally say that triangle RES is congruent to triangle SOR, and here I'm just going to use a shorthand of angle, side, angle. And I promise next time we'll have a new marker. Angle, side, angle. And that's it for today. We'll see you next time.